Welcome everyone to the class of the System Analysis and Design, subject code BCA204. Myself Gautam Kumar, Assistant Professor MMICT BM, MM Dim to be University. Today we are going to discuss about the structure analysis tools, and we will discuss about the DFD, data flow diagram, in this session. The contents which we are going to discuss: the introduction to the structure analysis, what is the tools used for the structure analysis, and we will discuss about the data flow diagram, or the another name is bubble chart, and its element and types. We have discussed the procedures used in building a computer based system and the role of the analyst in the system development life cycle. The goal of system development is to deliver a system in line with the user's requirement. Analysis is the heart of the process. It is the key component of first two phases of cycle. In phase 1, we focus on the problem definition and the initial investigation to solve that problem, and where analysis help us understanding the present system. And in the phase 2, the feasibility study, a detailed study of the present system is took place and completed, and potential solutions are determined to solve the requirement of the user. The outcome of feasibility is the system specifications that initiating system design. In analyzing the present system, the analyst collects a great deal of relatively unstructured data through interviews, questionnaires, on-site observations, procedures manual, and the like. The traditional approach is to organize and convert the data through system flow charts, which support the future development of system and simply communication with user. But the system flow chart represents a physical rather than a logical system. It makes it difficult to distinguish between what happened and how happened. Due to this drawback, the analyst needs something analogous to the architect's blueprint as a starting point of system design. It is a way to focus on function rather than the physical implementation. Structured analysis helps in solving the problem. And previously, we have the flow charts for showing a system design, and the flow charts only give the physical how the system will be give the output, but it is not showing the logical functionality, how the functions are taking place and how the solution of that problem is given to the user. So, eliminating or to cope up with this problem, we have another tool, that is the structure analysis, and we use several tools for the structure analysis. We will discuss in structure analysis here. What is the structure analysis? The structure analysis is a set of techniques and graphical tools that allows the analysis to develop a new kind of system specification that are easily understandable. Analysis work primarily with their intelligence, paper and pencil. Structure analysis considers new goals and structure tools for the analysis. The new goals specify the following: use of the graphics wherever possible to help communicate better with the user, differentiate between logical and physical system, build a logical system model to familiarize the user with system characteristics and interrelationship before implementation. We have some tools for the structure analysis like data flow diagram, DFD or bubble chart, data dictionary, structuring list, decision trees and decision tables. What is a data flow diagram? Data flow diagram is a technique developed by the Larry Constantine to express the requirement of a system in a graphical form. It is a pictorial representation of the system functions. This lead to module design. A DFD is also known as a bubble chart The purpose of bubble chart is to clarifying system requirements and identifying major transformations that will become program in system design. Data flow diagram or bubble chart. It shows the flow of data between various functions of systems and specifies how the current system is implemented. It is an initial stage of design phase that functionally divides the requirement specification down to the lowest level of detail. Its graphical nature makes it a good communication tool between user and analyst, or the analyst and the system designers. DFD gives an overview of what data a system process, what transformations are performed, and what data are stored, and what results are produced and where they flow in the system. A DFD consists of a series of bubbles joined by lines. The bubbles represent the data transformation and the lines represent the flow of data in the system. DFD describes what data flow rather than how they are processed. So, it does not depend on hardware, software, data structure or file organization. Basic elements of DFD. DFD is easy to understand and quite effective when the required design is not clear and the user want a notational language for communication. However, it requires a large number of iterations for obtaining the most accurate and complete solution of the problem. So, on the screen there are some symbols, basic elements of the DFD. So, symbol name is square and the meaning or description of use of that square symbol in the DFD is to show the source of the or destination of the system data, where the data is taken to process and where the data is going to in the system. Arrow is used for the data flow. The data, it shows the data in the motion. It is a pipeline through which information flows. A circle represent process that transforms incoming data flows into outgoing data. An open rectangle that is used for the data storage, data at rest, or a temporary repository of the data where data is stored in the system. We have two types of DFD. The first one is the physical DFD and the second is the logical DFD. And we can compare the physical and logical DFD through this table. Physical DFD, it is the implementation dependent. It shows which functions are performed, and logical DFD, it is the implementation independent. It focuses only on the flow of data between the processes. Physical DFD provide low level details of hardware, software, files and people who are interacting with the system, and logical DFD explains events of the system and data required by each event. Physical DFD depicts how the current system operates and how a system will be implemented, where the logical DFD shows how business operates, not how the system can be implemented. So, physical DFD gave the overview of the physical system, and logical DFD gave the functionality and the process of the that system which is going to be implemented for the organization. There are some rules which we have to keep in our mind while constructing the DFDs, like process should be named and numbered for easy reference. The direction of the flow is from top to bottom and from left to right. Data flows from source to destination. Process should be numbered if they are exploded into lower level details. The name of data stores, source and destination should be in capital letter. Process and data flow names, first letter should be in capital letter. context diagram. A context diagram helps in understanding the entire system by one DFD, which gives the overview of a system. It starts with mentioning the major processes with the little detail, and then goes on to giving more details of the process with the top down approach. The context diagram of mass management is shown below. So, context diagram is a single picture or single pictorial representation of the entire system, how the system have some modules and how they are connected to each other. For the example, on the screen we have a mass management system, and we can here see easily the different entities who are interacting and or different modules for that mass management system. Like a student has to make payments, student will get the bill, vendor have the requisitions, vendor will supply the material according to the requirement of the mass, and the mass management system or the who are governing that mass will pay to the vendor. Like mass secretary can interact with the mass management system to see all the things related to the students, vendors, mass managers and chief wardens. Same mass warden have some functionalities. So, it is showing which are the functions and how they can flow in the mass management system. It is an overview in a single picture. A data flow diagram can dive into progressively more detail by using levels and layers, zeroing in on a particular piece. DFD levels are numbered 0, 1 or 2 and occasionally go to the even level 3 or beyond. The necessary level of detail depends on the scope of what you are trying to accomplish. So, context diagram will give you the overview of the complete system, and you can further divide it or level it on the DFD level 0, DFD level 1, DFD level 2, and you can go beyond that 2 or 3 levels. DFD level 0 is also called a context diagram. It is a basic overview of the whole system or process being analyzed or modeled. It is designed to be an at a glance view, showing the systems as a single high level process with its relationship to external entities. It should be easily understood by a wide audience including stakeholders, business analysts, data analysts and developers. DFD level 1 provides a more detailed breakout of pieces of the context level diagram. So, in level 1 we break out or we create the DFD according to the modules. You will highlight the main functions carried out by the system as you break down the high level process of the context diagram into its sub process. DFD level 2 then goes one step deeper into the parts of the level 1. It may require more text to reach the necessary level of the detail about the system functioning. Progression to level 3, 4 and beyond is possible, but going beyond level 3 is uncommon. Doing so can create complexity that makes it difficult to communicate and compare or model the effectively of that system. So, there are some steps for creating a DFD. First of all, we create the list of activities in our system, and we construct the context level DFD, identifying the source and sink where the information is where the data is coming and where the data is going, and it is give at a glance picture of your system. After that, we construct the level 0 DFD that identify the manageable sub process. After that, we will go for the constructing of the level 1 DFDs that will identify the actual data flow and data storage. And finally, we have the check against the rules of the DFD. So, let us try to understand how DFD can be created and how DFD can be converted from context level to the 0 level, 1 level and beyond these. The operations of a simple lambnoid stand will be used to demonstrate the creation of the data flow diagram. I am taking here an example of the lambnoid stand. So, think throughout the activities that take place at a lambnoid stand. So, that can be first the customer will place the order, then the server will check for the availability of that product and serve the product if it is available, and the customer will pay for that product that has been served by the server. So, step 1 for the DFD to create the activities. So, there could be some activities like customer order, serve the product, collect the payment, produce product and store that product for the further consumer consumption by the consumer. Also think the additional activities needed to support the basic activities beyond these activities, because these are the primary activities for that lambnoid stand: customer order, serve the product, collect payment, produce product and storage of that product. But beyond these we need some activities to support the basic activities like order the raw material for production, pay for the raw material and pay for the labor who are engaged in producing the product at the organization. So, we can arrange these functions or activities in categories like function 1, function 2, function 3 and function 4. In function 1 what we have? We have the customer order. First of all, customer will come to the stand and place the order, and the server will serve the order if it is available and collect the payment. Function 2, produce that product for the next customer, store that product for the maintaining the supply chain. Function 3 is ordering the raw material, pay for the raw material, and function 4 is pay for the labor. So, we will discuss the DFDs on the base of these function in detail. Like first of all, what we have the context level DFD for that lambnoid stand. So, what we are doing in creating the context level diagram, we are identifying the source and sinks or users. So, here on your screen you can see that is the context level DFD for the lambnoid stand or lambnoid system. The customer will place the order and the product will be served to the customer and customer make payment. It is showing how these activities will take place to that lambnoid system. Employee who are working on that lambnoid stand says the forecast, sales forecast, predict how much product he or she need to produce for the selling, production schedule, take the payment and time work, and the vendor receive the goods payment, purchase the order and many more. So, it is showing how the activities will take place for that particular lambnoid system or lambnoid stand. Now, what we are doing? We are creating the level 0 diagram for the identifying the logical subsystems that may exist. Like for customer, we can have a different module, the sale. The customer can place the order through the sales module and make the payment for the same sale module. Employee can take the sales forecast on the basis of the previous sale, finding the trends. Production, there will be another subsystem that may exist in the lambnoid system, the production and procurement and payroll. There will be the 4 basic subsystem for the lambnoid system: the sales, production, procurement and payroll. And we are showing the relationship with the arrow between the customer, vendor, employee with these 4 subsystem of the lambnoid system. Now, we are creating the level 1 DFD for customer order and collect the payment. So, customer will that is the level 1 DFD on the screen. Customer will place the order, that will order will be stored into the order. From that storage, what we can do? We can check produce sales forecast. If we are taking too much order, we have to we can easily forecast how much we have to produce, and all these functions are connected to each other by showing the arrowhead from the data is flowing from tail to head. It is giving the activities in detail, overview of the activities which are taking place in detail for the customer order and collect the payment. Same we have the DFDs, level 1 for serve the product, produce product and store the product. As we have already categorized these activities in function 1, function 2, function 3 and function 4. Same we have level 1 DFD for serving the product, storing the product and producing, and these arrows are showing how data is flow from where to where, and these circles are showing the process where that data is processed and outcome will be given to the that particular raw material. Same we have the level 1 DFD for the ordering of the raw material, payment of the raw material, and you can easily understand here we have process we have three different process like produce, purchase order, receive the items and paying the vendors, and these are the data storage, and we have how the data is getting the order decision to produce the purchase order, and that will process that data given to him from various sources, and it will send the processed data to the sink or the users or the destinations. Same for the payment of the labor, we can have the time cards, employee ID, payroll, payment and sub processes like time record, recorded time work, how much hours a person took to the organization, according that we can create the salary and all these things. And that is the process decomposition of that laminoid system. First of all, we have the context level and we have the overview of the laminoid system. After that, we find subsystems like sales, productions, procurement, payroll, that will be easily shown by the level 0. And after that, we have the more detailed DFDs of the level 1. Sales can be break down into the record order and receiving the payment. Production can be break down to the serve products, produce the product and store the product. Same procurement can be break to the production, produce the purchase order, receive items, pay the vendors, and same for the payroll. We have time record time work and calculate the payroll and pay to the employee. So, that is the overview of that DFD for the laminoid, how the a context level diagram can be divided into the level 0, level 1, and how it will give you the proper communication and well formed information in a pictorial representation to communicating with the user and the system developer by the system analyst. These are the references for the session. Thank you.